Alright guys, going to talk about double and half angle identities. The double angle identities we've already done before, but I just want to give them to you again because they are going to be on your next test. They were not on the test that you took today, but they're going to be on the next test. And so I'm going to give you the double angle identities. I'm going to do an example just to kind of refresh our memories on that, and then I'm going to show you the half angle identities, and I'll do examples of that tomorrow in class. So double angle identities, remember what that means is we're doubling the angle, so now we have 2 theta rather than just theta. You have these formulas already given to you in your notes. I do want to remind you that the reciprocals still work. For example, the sine of 2 theta, if I flip that and do 1 over sine of 2 theta, that is the cosecant of 2 theta. So if I ask you to find the cosecant of 2 theta, we can still find that information by doing 1 over the sine of 2 theta, and the same thing for the secant and the cotangent. So I want to do this problem here just to refresh our memory. It's a triangle problem, which we've been doing, but I just want to go back over it to make sure that we understand how to work double angle problems. So it says find the exact value of the cosine of 2 theta if the sine of theta is 7/25 and pi over 2 is less than theta is less than pi. Now remember, this right here is telling me what quadrant I'm in, and that's important because it tells me whether my answers are positive or negative. So this is 90 degrees, pi over 2, and that's 180, so that's going to be in quadrant 2, which means my x value is negative and my y value is positive, okay, or cosine is negative and sine is positive. So what we're going to do here is we're going to draw our triangle. And we're going to put theta down here at the bottom. And if you remember, sine is opposite over the hypotenuse. And then to get our other leg here of the triangle, we do the Pythagorean theorem. So 7 squared plus b squared equals 25 squared. So 49 plus b squared equals 625. B squared equals, let me think, 625 minus 49. That's 576. And if we square root, we get 24. Okay, so this side comes out to be 24. So now what we want to do is we actually want to solve this using the formula for the cosine of 2 theta. So the cosine of 2 theta, and we can't just use the cosine of this triangle because this triangle is for theta, not 2 theta. Okay, so the cosine of 2 theta, and I'm just going to use the first formula, cosine squared minus sine squared. Okay, you could use any one of the 3, but I'm just going to use that one. Alright, so now, if I find the cosine of this triangle, the cosine of theta is 24 over 25, so I got 24 over 25 squared. And then, and by the way, we are in quadrant 2, so that should be a negative 24 there. Don't want to forget that, because my x value should be negative. So negative 24 over 25 squared. And then my sine is 7 over 25 squared. So let's see. When we do 24 over 25 squared, we end up with 576 over 625 minus 49 over 625. And they already have a common denominator, so we take 576 and we subtract 49, and we get 527 over 625, and that is the cosine of 2 theta. And that's how you work those double angle problems. Okay. Now, if I were to ask you for the secant of 2 theta, all you would have to do is flip that. All right, so that's double angle problems. Now, let me show you the identities for half angle. Very similar to double angle in the sense that now with a double angle we're multiplying it by 2, but half angle we're now dividing them by 2. Now notice these formulas look a little crazy. Everything has a square root, so that's why we have the plus or minus. But notice they're all very similar. For the sine, we do the square root of 1 minus cosine over 2. The cosine is going to be 1 plus cosine over 2. And the tan is going to be 1 minus cosine over 1 plus cosine. And the square root of that. Okay. So, why do we need the double angle formulas? Well, it helps us when we need to find so angles that are half of those angles that are on our unit circle. So looking at this problem here, it says find the exact value of the cosine of 112 degrees. Okay. Now, ordinarily, we would take that and we would look on our unit circle and we would find that exact value. But 112.5 degrees is not on the unit circle. But if I were to double that, in other words, multiply it by 2, it gives me 225 degrees. Now, 225 degrees is on my unit circle. So what I'm going to do is I'm going to rewrite this problem as the cosine of 225 degrees divided by 2. So basically what I did is I just made it a half angle problem, because I took a degree measure, an angle measure that I knew was on the unit circle, and divide that by 2, and that gives you the 112.5. But I can deal with this one. So what I'm going to do is I'm going to apply the cosine formula to this. So plus or minus the square root, and we're going 1 plus the cosine of theta. Now this is theta, my 225, all over 2. So when we simplify this out, we get the square root of 1 plus, now the cosine of 225 is negative square root of 2 over 2. And all that's over 2 now. Now that looks really, really messy, okay? And what I'm going to do is I'm going to start here tomorrow, and I'm going to show you how to simplify that, just so that we can clean it up a little bit, because we've got a lot of square roots and stuff going on there.